Putting together a computer system is easy. Putting together an application is not. It used to be that programs required users to manipulate information in very peculiar, restricted ways. Everything was dictated by the system, right down to the order of operations. The user became a peripheral to the CPU. The Macintosh computer is different. Building an application for the Macintosh is like creating an entire environment in which users will move comfortably and work productively. Unlike the applications of old, where we, the designers and programmers, were the stern yet kindly father who would guide users down the right and proper paths, often preventing them from getting their work done in any kind of a productive fashion. With the Macintosh, that's all turned around. We construct a reality, a world in which the user will work and live and feel comfortable. We're in the subterranean world of a hotel complex. Nothing very natural here. This is a lot like the interfaces we used to present our users. Dangerous, confusing, confining. This is the operating system of the hotel, supplying power, water, communication. All necessary, of course, but not the sort of place the user should ever have to deal with. Like many computer programs of the past, there's plenty of functionality here, but no way for normal users to be able to access it. It's a world only an engineer could love. As programmers and designers, we're condemned forever to wander the twisty passages of the operating system. But like the hotel, we've created for Macintosh users a separate virtual world upstairs. A world where they can operate comfortably. Now, this is a world a user could love. No maze of twisty little passages here. Instead, they have carefully constructed a reality 3 stories above the street, above the operating system, in which the user can feel very comfortable. And it's not just beauty, it's functionality. I'm surrounded here by every service I can possibly imagine, seemingly within arm's length. Just as on a Macintosh, we surround the user with every service the user needs within arm's length using the mouse. The user need not navigate. Services are brought to him or her. It's user-centered design. Through careful design and placement of various resources, the designer has presented me, tempted me with choices. Choices I can make according to my own needs. This restaurant and the entire Hyatt Regency Hotel in San Francisco are here to guide me in ways that will make me successful, not dictate to me. They didn't determine that I must register before I'm allowed to eat. I was able to do it in whatever order I wanted, although there's a greater range of options open to me if I register first. I've only been in this hotel lobby for a short time, and yet I find it difficult not to believe that I'm on the street level and outside as they wished me to believe. Similarly, when I look at a file folder on a Macintosh screen, I find it impossible to believe that it's just an arrangement of light. When we set about to fool the senses through a carefully constructed reality, it becomes very important that we have no hidden rules that violates the user's sense of trust. When the illusion is shattered, when the safe feeling is suddenly jerked out from under the users, they become confused, frustrated, and finally, they take their business elsewhere. Just like the Macintosh world, the real world is made up of familiar defined objects. For instance, the hotel registration desk. As I reach the registration desk, the registration object, I bring with me a whole series of expectations of what activities will take place. I expect to fill out an information form. I expect to hand over my credit card. I expect to receive in return a plastic room key. These are all objects, sub-objects of the registration object. And every object has certain elements that forms it. For example, the bell object, which summons the innkeeper. A standard visual appearance, a standard way of interacting with it. A standard behavior that results, the sound of the bell. the arrival of the innkeeper. These are universal throughout the world. This is a defined object, a group of elements bound together. Once an object has been established, once the binding has taken place, it is very important not to unbind it. For example, if I ring the bell and it sounds like a cowbell, I will be confused. I'm no longer sure whether the innkeeper will arrive or something else. Once we've created an environment, it's up to the users to change it, not us. Stability means that we won't change the environment without the user's knowledge and consent. For instance, as you go from one rev to the next, don't change the meaning of Command I, meaning italics, to Command I, meaning initialize the hard disk without prompts. Fortunately, most things in the real world are quite stable. This electronic car, however, is not naturally stable, and it becomes the responsibility of the programmer and the designer to provide that stability. I bring my car to Ralph's garage and computer programming because Ralph, even though he likes to tinker around and add an item here and there, he understands stability. He would never make a change without letting me know. Ralph's new feature of washing the windows every time I started the car was all wet, and so was I. This is a convertible. Direct manipulation is simply the idea that people want to communicate with their environment through physical actions that produce immediate responses. For example, in an automobile, I can directly manipulate the speed of the car with the gas and brake pedals. Similarly, if I want to change the direction of the car, I can directly manipulate that direction by simply turning the steering wheel. Except that Ralph, you see, he's an old basic man, and he decided that I'd probably rather change the direction of the car by typing left and right on the keyboard. Ralph! The real world can be a dangerous place. Consider all the explorers who never came back. For a dangerous real-world environment like this to be made safe requires we offer people some protection. The Macintosh world can go the real world one better. First, we can provide a much safer, flatter environment for the user to explore. And then when the user does get close to an edge, we can provide alerts. For example, let's say I wanted to walk off of that cliff or initialize my hard disk. The system would give me an alert asking me whether I was sure I wanted to proceed. Then if I did, it's my responsibility. Undo! In the final analysis, human interface is a business issue, not a religious one. And Apple is putting its money behind educating to the public to the importance of consistency in the Macintosh interface. This is where a new software product first meets the users, but only if a salesperson chooses to introduce them.
There are products that even today where, although they're very powerful, we will still throw in, gee, it's great, but the interface is a little shaky. If that's a problem for you, you may want to look at something else.
Word of mouth is always the most important thing in selling any product in any market, not just in computer software. That's a fact. So if the interface isn't right, if the program doesn't feel right, and if people say, oh, that's not very Mac-ish, then it's not going to be successful in the long run because somebody will come along and do it better.
Macintosh users are even more picky than the residents of a luxury hotel. Macintosh users know the language. They know the objects. They know the behaviors. They will expect to be able to understand your constructed reality by the way these objects act. And remember, Macintosh users are tough customers. They expect consistency. They expect stability. And if they don't find it, they'll go somewhere else.
I have a strong sense that there is a Macintosh developers community. There's a lot of us who've always, over the years, talked with each other. We have a lot of mutual goals. We want to make our software as good as it can be. Even if I'm competing directly with someone, I would still want to see them make their software be Mac-ish, have a very good Macintosh user interface so that all products for the Macintosh are superior, that enhances that product, the Macintosh computer itself. And to the extent that there are more sales of Macintoshes, we all benefit.
There's a revolution going on in the world of architecture. For years, computers at Harvard University's Graduate School of Design were mainframe systems that had little impact on teaching. Now, the Macintosh is making graphic computing an essential part of every student's design process.
When computing was first introduced into design schools, the machines were put in a laboratory in a back room someplace with white-coated attendants, and mysterious things happened in that back room. And the only way that you can do creative design work is to have the technology accessible where the action takes place. It enables us to model a building in 3 dimensions rather than working with 2-dimensional drawings. It enables us to simulate the dynamic experience of moving through a building. So it's an enormously powerful teaching medium. It just jolts the imagination into completely different territory.
It was just an accident that I started to work with computers. It was just a moment, you know, like a light bulb, you know, in your head, and I said, that's the thing I want to do. You build up the building in any manner you want. You add up surfaces, you connect them, you add color, and then you produce shaded images, and then do image merging. I just wanted to bring some sense of reality to the design. You know, some sort of a movement, cars are moving, you know, you have sound. So you really feel the building in its site, you know, in its context. It's really there.
Three-dimensional modeling and image merging with the Macintosh are just 2 of a broad range of applications being used at Harvard. With Pixel Paint Professional, Digital Darkroom, Photomac, AutoCAD, and SpectraVision, student designers reference full-color digital files of existing sites and render new structures.
The computer does offer whole new vistas. You can work with long shots, you can work with zooming in close-ups, you can have perspectives, different points of view.
This semester, students will design a brand new Bunker Hill monument with the Macintosh.
And when you take pictures of it, remember that it's really the context that we're photographing, not the monument itself, because the monument itself is going to disappear. We'll bring these images back to the Graduate School of Design, and we'll capture those images in digital format, and then we'll use them as a basis for image manipulation.
You really do have to use your imagination to see it. And actually, that's where the computer's handy for me, because I can play with many different options and see variations on a theme.
He's going to get a real surprise when he develops that film.
In the past, computer-aided design in the classroom was both impractical and costly. Now with Macintosh on the desktop, all that's changed.
In order to make animations, you need a lot of machine cycles, you need a lot of memory, you need a fast, powerful machine. We need to make sophisticated images, so we need high resolution, good color. Now that the cost of computing has dropped, particularly graphic computing has dropped to a much more reasonable level, we're actually able to use it on a daily basis, on a large scale, and that's an enormous difference.
I like my personal excitement, you know, when I want something to be done and when I see the result exactly as I want it, you know. And it's, you build some sort of a relationship between you and your computer, you know. It's like, you know, a good friend, you know, that is always there.
history, geography, presented in an exciting new form, multimedia, bringing video and the computer together in the freshest way possible with the impact of National Geographic images, the interactivity of the computer, the instant access of the video disc.
Well, when I first saw it, I didn't know what to expect. I didn't know whether it would be hard and that you'd have to know a lot about computers and a lot of technical stuff. But then once using it, it was really easy and it was kind of self-explanatory, you know. It like took you step by step.
But I think the easiest way to describe GTV is that it's something to show and something to do. Now the show part of GTV is that the video discs themselves contain, like bands of a record, they contain some 34 shows, and each of those shows provides a geographic perspective on U.S. history. A teacher can stand in front of the class and he or she can simply present the material to the class as the beginning of the lesson, as a motivator, as something to stimulate discussion.
2 hours of fully produced video. With 1,600 photographs, 200 maps, motion footage.
The other thing that GTV is something to do. And the to-do part of GTV is that you can make your own presentations. You can put the shows in the order that you want. You can write your own shows. You can use GTV as a database that allows you to search for information on a topic.
A table of contents so you can access a show instantly. A keyword search function so you can search by topic or theme.
Oh, World War II. They should have World War II.
Yeah. Look at that. That's awesome.
Oh,
It looks like
cool.
We interrupt this program to bring you a special news bulletin. The Japanese have attacked Pearl Harbor, Hawaii by air.
GTV can be used in so many different ways. It's really a springboard. It's a springboard to the library. It's a springboard to an atlas. It's a springboard to group work. It ignites children's imagination.
These are all interesting.
A caption for each picture. A synopsis for every show. A rich new resource.
Like encyclopedias deal more with information and only words. You know, they might have a few pictures, but GTV is more visual, and you can get a lot of movies, and you can like if they're talking about political leaders, you can see the leaders, you know, and you can really get a better feeling about what you're studying. You got to look through a lot of stuff and get to pick what you wanted, you know, because then you'd have a choice, you know, and then it was fun looking at all the different newsreels and the pictures and everything. It was really interesting. It was really good pictures to look at.
How Americans were alike.
When you produce any imagery, you're wanting to think about what you say. That happens whether you're working with words or with images. The nice thing about this is that you've got many students out there for whom the written word is a tough thing to work with. This gives them the same chance to work with how do I say what I want to say, how do I present what I want to present, but in a medium other than the written word.
That's a good picture because that the North had more factories and more business-like people than the South.
I mean, history is a story, and it's a story of real people living in a real place with a real idea of how the world works, and it's not been the same throughout history, how we felt about who we were and what we did and where we lived. And part of what GTV does is to bring the emotion that's behind history, and part of that emotion is what you think about where you live and what you do.
A fresh angle on old ideas.
Christopher Columbus sailed from Spain in 1492. Wanted to reach Asia. Hit the Americas instead. Wanted to strike it rich for himself, for Spain. Picked up a little gold. Didn't get rich.
1920.
Yeah.
That's the
Okay, FDR. Okay, put
40s radio, 40s radio. FDR.
Okay, put all those on there.
Farm.
First, get rid of these.
When I see eyes that light up, I know we've done a good job. History is a tough subject to teach, and it's such interesting material, and you want to catch them on fire, and if we can do that, that's a real good thing.
A flexible approach to the basics, and plenty of fun along the way.
With the Mexican cession, we gained western land, and our southwest border reached the Rio Grande. The Gadsden Purchase was made in 1853, and then the country stretched from sea to shining sea. Then Russia had land that she wanted to sell, a place called Alaska that few people knew well. So I guess with that, my map rap is through. We've gone from coast to coast and Alaska too. Dig this map. Now you've heard my rap. Dig this map. Now you've heard my rap.
At 2:31, there's a shot of a building. They're panning down a building. Could you show that to me and show me what that looks like, please?
It was really the needs of the department and the kind of scheduling that we needed to be able to do that drove the decision to go to Macintosh. We wanted a graphical interface. We had to, for purposes of scheduling, to have the schedulers be able to see a real representation of what they were doing. Our idea was that the schedulers would spend more time thinking about scheduling and less time working on the details of what they were doing. It was clear early on that there was far too much detail work that the schedulers were doing, and it was cutting into their time of really thinking about how to creatively schedule people, how to match up the right editor with the right producer.
What we did before is that you had this green piece of paper, this chart, which was a mustard-colored, ugly green, and you had to pencil in their hours, and it was this big. You'd have to draw a line, you would have to put in their dots, you would have to put in their lunch hours, you'd have to put in the show, you'd have to put in their EJ rooms, edit rooms, and the name of the person, week after week after week.
After Hours Software specializes in developing customized databases and integrated systems which involve the Macintosh family of computers. We'll develop systems which involve both Macintoshes and VAXs and IBM mainframes, and we develop databases which can communicate information back and forth to provide the best solution of power and interface. NBC came to us because they had a specific scheduling need, which they saw a really good solution for in using the Macintosh.
And when we looked at the Macintosh, and particularly when we looked at 4D and the timeline program, we felt that we had a winner. The schedulers were spending far less time on the mechanics of scheduling and a lot more time on thinking about who should work with who on what story and when. And that's really what drove the process.
Fourth Dimension is a database application for the Macintosh, which allows you to create a complete customized interface and also access a local Fourth Dimension database or a remote SQL database on a mainframe. It's very powerful because it gives you the complete interface of the Macintosh while giving you access to the corporate information and systems such as Oracle or Sybase or RDB. The learning time for Fourth Dimension is very short, and that usually gives the MIS people we're training the ability to quickly pick up the system which we've developed and understand how it works and learn from the example which is specific to their particular needs, and they usually can quickly get into modifying it, maintaining it, and developing new systems for the future. One of the really powerful features of Fourth Dimension is that we can prototype a system so quickly that you can actually figure out what it is you want the system to do without having to spend months and months of time to actually implement a prototype. One of the powerful features of Fourth Dimension is that it gives you full control over the Macintosh interface. So you can create a program that looks just like a regular Macintosh application. Here in the design environment, for example, I can choose this label on one of the fields, and by using the menus, I can even go over and give it a different color. So instead of black, I can choose magenta. I can change its font to be a different font. I can change its style. I'm going to do that. Let's say we'll make it 18 point instead of 12 point. And I can go back into the application and run it and see that that information has actually been changed to the new type and style that I set. And that's really important because you can create an application that runs just like a Macintosh application, and that's what people are familiar with, and that's really the power of the machine.
Hi, Judy. How are you?
Hi, Walter.
I see I'm working at 24. Could you tell me who that job is for?
Yeah, you'll be working for the Today Show until 7.
We schedule 64 staff editors, and we have 24 per diems or daily hire people who would take over facilities if the other people were on vacation or ill, et cetera, et cetera. And scheduling 88 people by hand could take over a day. Scheduling it by computer, once it's written in and completed, takes about 2 hours.
Ever found yourself in a situation like this? At Apple, you can eliminate paperwork and the worry of having it arrive on time. Hi, I'm Lynn Lascola, coordinator of Apple's electronic mail system, or as we refer to it, email. It enables you to send messages to others. Let me show you. I log on to email with my ID and password. The individual password guarantees security. Then I can either send or receive a message. Once I've entered, the system automatically tells me who sent the message, a message number, and date. The printer can make a permanent record. Messages are stored and retrieved for up to 14 days. Before I reply, I can write my message using Apple Writer, VisiCalc, or Pascal. When a confirmation shows on the screen, the transmission is complete. The message is waiting to be read. Email training classes are offered on a regular basis. In 1 hour, you can be a pro. Come join the international users of email and make this a scene of your past.
The retail business in general is a very dynamic business, and change is constant, and the guy who is in the position to react the fastest to the changes of what our customers are looking for is the guy who's going to come out on top. Montgomery Award is a company undergoing change in terms of switching from the strategy of being a mass merchant to a chain of value-driven specialty stores. The chain currently has 320-some stores, and we're looking to add several hundred specialty stores and full-line stores in the next 5 years. In terms of the specifics on how that would affect a store planning department, the expansion basically is going to mean to us the production probably on an annual basis of in the neighborhoods of 60 facilities in some way, shape, or form, both existing stores and new stores that'll be coming through this shop. And with that in mind, it became necessary for us to find more efficient ways to actually deal with this workload.
Speed is very important in doing CAD. It's perhaps the most important factor. Refresh rates for the graphics determine the rate at which you are able to work on the machine.
As far as using the machine, we found that the people using the Macintosh are basically allowed to get off and kind of train themselves. The intuitive abilities of the machine, for one, to sit down and operate it versus having to sit down with the manuals on a DOS machine. It has proven to be a real benefit for us.
On the Macintosh, you basically have your pull-down menus, dialog boxes, windows, etc., which are standard among programs. When you learn a program such as VersaCAD and you decide to go to something like Microsoft Excel or another application on the Macintosh, you're able to convert to that program easily because of the interface. Therefore, your learning curve has dropped to almost a straight line when you've learned one application on the Macintosh.
When I went to school, I learned just with the pen and ink. I didn't have any computer training whatsoever. When I came to Montgomery Wards, they started the Macintosh program and got me started with the computers and teaching us how to do everything, and it was real easy. The stores are drawn a level at a time. If they want to see just certain parts, like if they just want to see all electrical, they'll shut all levels off and keep just the electrical levels on.
If you were going to look at a Montgomery Ward store today, you'll see a building set up with front entrances, separate entrances for our Electric Avenue and our kids store, and a main entrance that would actually relate for the rest of the store. The building is meant to be open, easy to shop, and above all, the building is meant to be flexible. The grid system that you'll see in the ceiling is once again very supportive of change. I mean, the ability to take a fixture out, drop a different type of fixture in, depending on the merchandise presentation that's going on below, are part of the flexibilities that are now being built into our facilities. The whole goal within a retail facility is to make it comfortable for the customer to shop. From a standpoint of remodeling a facility, the Macintosh is really of benefit to us because of the constant change within a retail store. If we were just going to produce these drawings once and then put it out for the next 20 years and leave it untouched, there probably wouldn't be much value to the effort that we're going through. But it's the constant change that actually causes the computer to be of greater value to us. Retail is a changing business, and at the end of this program, somebody's going to come up with the next round of changes that need to be implemented, and we're going to be in a much better position to react to those changes.
Personal computer is the one that you don't have to learn how to use. You have to know what the on switch is. And from there on, the computer does the computing.
We're all human, and I think we all enjoy when we see our customers and they pull out this computer and they go, wow, this is really neat.
What makes me sweat the extra details is that this is going to be real important to somebody.
You don't see the drive for perfection, that's us. I mean, you don't see it, it happens. Go to the staff meetings, watch the art and see it happen.
It's like sitting down in front of a desk with 1,000 paintbrushes, 1,000,000 different words, and a bunch of different typefaces, and 25 phone lines, and you're connected to the world.
We started out using the local talk, which is extremely simple. I mean, if you want to get started with networks, that's about as easy as it's going to get.
Probably the output coming out of the laser writer is one of the biggest things that hit us. When I laid this on the table, my report was head and shoulders above everybody else.
I had 4 of them wired up and singing Stand By Me a cappella. That was real good.
When somebody comes in and we interview them,
we ask them, what do you want to do on the Macintosh? And the people that we hire are the people who just start talking.
There's a sense of doing things that people haven't done, of trying to make things workable that haven't been worked, a sense of doing something significant and meaningful that just inflames you for your work.
We have the power to make a difference. Other companies say you have the power, but we have the power to do it. We build stuff like this, and we take them up on it. We say, okay, we'll change the world. I'll sign up for that.
With a Macintosh, the machine doesn't control you. I control it. I tell it I want this here, I want this thrown away. I'm in control of it.
I guess the revolution in the Macintosh is that it is so obvious to use.
They should never perceive this thing as a computer. They should call it something else. They should call it a, I don't know, call it a, I don't know what you would call it. You shouldn't call it it's not a machine.
Please welcome the chairman and CEO of Apple Computer, John Sculley.
Well, thank you very much, and good morning and welcome, and particularly welcome to all of those people who are watching us across the country by way of satellite, because this is our first new product introduction for the decade of the 1990s. I hope you enjoyed the video as much as I did, because those are our engineers, and there are many others just like them. They're people who are passionate, who care about the products, who came to Apple to do extraordinarily great things. And in the last month or so, I've had a chance to go around and visit a lot of them, to see demos, to watch what's in the pipeline. And there's just a tremendous amount of exciting technology going on at Apple Computer. And a lot of that is being converted into products, and those products are going to be coming out, some today and some out in the future. But I want you to know that the excitement that sets Apple apart, I think, is this passion to do extraordinary things with technology. So what we're going to do today is to have the people who actually worked on the products that we'll be introducing be the ones to tell you about it themselves, because the depth of our talent really runs deep at Apple. And I think it's kind of neat to hear from the people who have been involved with these products from their early inceptions. First up, though, I'd like to give you a little bit of perspective of what you're going to hear about. You're going to see the most advanced Macintosh technology that we've ever done so far. And yet it's still going to have the simplicity and the elegance that means it's a true Macintosh. And then you're also going to see some new cards. Now, these cards are extraordinary in what they're able to do, particularly for the new product that we'll be showing you, the new CPU. But even more important, I believe, for users and for the success of Apple is what these cards can do on any Macintosh new bus computer. So, for example, if you had a 1987 original Macintosh 2 and were to put these cards in, you would get the benefits of these new technologies in terms of the added performance. And it just goes back to underscore how everything Apple does is integrated to make the system software work very effectively, to be optimized with the hardware. The third thing is that we're going to be showing you, I think, a new benchmark for excellence in the Unix world with AUX. And just before I came out here this morning, the AUX team gave me a T-shirt. What would Apple be without a T-shirt for a new product intro? And this one says that it's going to be Unix for the rest of us.
The year is 1969. While Neil Armstrong takes a small step onto the moon, scientists at Bell Labs develop a new computer operating system called Unix. The moonwalk makes bigger headlines. Throughout the 70s, Unix begins to spread to universities and government agencies around the world, despite violent student protests. The demonstrators claim that Unix was designed for counterculture computer programmers, not for the common man. During the Reagan era, Unix gets more popular as the installed base grows from 45,000 to 250,000. University researchers like Unix because it lets them run the same software on the potpourri of computers that have been donated to colleges over the years. But normal people are befuddled as different versions of Unix and a torrent of industry standards crop up. SVID, SVVS, POSIX, TCP/IP, NFS, BSD, even X11R4. Confusion reigns in the Unix marketplace. In 1984, the Macintosh is introduced, and Unix users experience more than a twinge of envy. And in 1988, as George Bush campaigns for president, Apple introduces a kinder, gentler Unix. It's called AUX. The following year, as the Unix installed base passes the 1 million mark, Apple adds the ability to run Macintosh programs on AUX. Unix users sense a new wave of hope. 1989. In Eastern Europe, millions of protesters take to the streets demanding freedom and Unix with a meaningful interface. And as the new decade begins, rumors circulate in Silicon Valley that Apple has created a new version of AUX, extending the full benefits of Macintosh to the waiting Unix world.
AUX 2.0 is solid Unix, and this is AUX running on top of the Macintosh platform. And if you've ever used Unix, you'll recognize this. This is a standard listing using the ls command, and it gives me a little bit of information about files and subdirectories that are on this particular file system. I'm going to use the command ls-C F to get a little more information. You can tell that anything with a slash after it is a subdirectory. Anything with an asterisk is an executable file. There's a subdirectory here called /demos, and that looks pretty interesting. So I'll use the cd command, which stands for change directory, to get into /demos. And I can't really tell if anything happens, so I'll use the pwd command, which stands for present working directory, to see if I went anywhere, and I did. And again, I'll list my files, and I see there's some new files there. On a Unix system, you're going to want to move some files around, so I'll use the mv command, which stands for move, and I'll move init tab and alco to a new folder. And you'll notice that I have to use a backslash to escape the space in the word new folder, because Unix can't deal with spaces. And again, I can't tell if anything really happened. Well, this is Unix, but with AUX 2.0, there's a better way of accessing the thousands of files on a Unix system, and that is the Macintosh desktop. You still have access to your files in the familiar Finder way. You have access to pull-down menus, the same desk accessories that you expect on the Macintosh. And this is the Macintosh desktop on top of an industry standard Unix. New icons have been created for use with AUX 2.0. You'll see Unix text files here. This is a Unix utility. This is a Unix binary. And this is a Unix shell script. Well, I'm going to go into /demos. Notice that I don't need to use cd commands and things like that to navigate the file system. And I can move files and manipulate my file system again in the familiar click and drag way. And I'll just take a file and drop it into a new folder. So you can see there's a very powerful way to access the thousands of files that are on a Unix file system. On any Unix system, you're also going to want to use printers and file servers. Well, in this case, we'll take a look at a file called etcprintcap. And this is a file that establishes defaults for printers on the network. And if you want to change your default printer, you've got to go in and tweak this file. And it can be very difficult, and it's very cryptic. Networks are pretty much the same case. Take a look at a file called etchost. And this shows some of the IP addresses for different servers that are out there. And this is the you show me your IP address, I'll show you mine game. And it can be tough to play. Again, with AUX 2.0, there's a better way of doing it. And that is the chooser. And if you're familiar with the chooser, you know that this is a powerful way to access network resources. By selecting the Apple Share icon, I could select a file server as the list appears where my cursor is. I can select printers in the same way. Click on the laser writer icon, and I can then select different laser writers that might be out there on the network. Just as the chooser is a powerful way to access network resources, AUX 2.0 is a tightly integrated system that provides power and ease of use to our AUX customers. Well, this is where the AUX story becomes truly interesting, and that's in the ability to run multiple types of applications on the AUX desktop. I'm going to bring up an application called Swivel 3D and a document called Plug. This is a 3D rendered image of a standard 3-prong wall plug. And you can see that the performance of the Macintosh is passed through to AUX as well. And I can manipulate this 3D image, and you can see the responsiveness of AUX 2.0. Well, on the currently shipping AUX product, you can only run one Macintosh application at a time. But with AUX 2.0, you can run basically as many as you can keep track of. This is a chart that I created in Excel. It's a simple chart, and we'll put that on the desktop. With AUX 2.0, you can run the many Macintosh productivity applications that are out there and that have made the Macintosh famous. So in this case, you see the application Swivel 3D and the application Microsoft Excel on the desktop. This is a powerful feature for AUX customers. I'm going to hide these Macintosh applications, take them off the desktop, and bring up MacX. MacX is one of the X Window System products that's available for AUX, and it provides access to the X Window System for experienced and inexperienced users alike. I can, from a pull-down menu, select X Window System applications that I might be interested in using. In this case, I'll pull down X Logo. There aren't a whole lot of applications available for the X Window System, but as they become available over time, you'll be able to use them with AUX 2.0. In this case, you see X Logo on the desktop. Well, let me hide MacX, and I'll bring up some Unix shell windows, and these are called command shell windows. These are just basic Unix sessions, and in them I can run standard Unix utilities that I might happen to know how to use. In this case, PS, that's a process status, gives you some information about processes that are running on this AUX system. I can also run standard shell scripts. This is a little gratuitous advertising, but you can see here that I now have access to all the applications, all the character-based applications that have been written for Unix. Well, let me pull back the other environments, the other applications. I'll bring back Swivel 3D, and I'll bring back Microsoft Excel, and we'll pull back up MacX. And what you end up with is a cluttered desktop, but you also end up with access to the Unix file system, access to multiple Macintosh applications, access to X Window Systems applications, and access to all the character-based Unix applications that are out there. This is a powerful combination, and no other vendor can provide this type of integration on the desktop, and no other vendor can provide Macintosh applications either. AUX 2.0 truly extends the Macintosh experience to Unix. With AUX 2.0, you can perform daily Unix tasks in a much easier way. That's the Macintosh way. A traditional strength of Unix has been the availability of hundreds of powerful utilities. But typically these utilities have hard to remember names like awk and grep, and they have options that are even harder to remember. Well, with AUX 2.0, you still have access to the power of these utilities, but you have access to it in the familiar click and point way. As an example, I can just double click on the ls command rather than having to go through a command line. I'm presented with a dialog that allows me to select options for ls without having to know what these options mean. As an example, if I want to mark directories, that's a -P. And you can see on the command line that ls-P was built for me. As I select other options, those options will be added to the command line as well. So list all files is a -A, long format is a -L. You'll also notice that as I select options that in the help window, a little information on each option is provided for me. So I can select the options that make the most sense for the task at hand and then execute that command. And in a shell window, the output is presented. In this case, it's the output for ls. So now, general users or casual users of AUX have access to the powerful Unix utilities that are there, but they don't have to remember the long list of options that are available. Another task that you'll typically want to perform on an AUX system is editing text files. And on any Unix system, there are hundreds of text files used for everything from configuring your system to just the standard work that you'd create. I'm going to use VI, which is a screen-based text editor, to take a look at a file called password. And this is a file that is typically used to maintain a list of users or accounts on a Unix system. And VI is a very difficult text editor to use, but there's a lot of power in it as well. But just to demonstrate, in order to move through this file, I have to use the J key to move down through it. I want to cut the line called guest and then paste it back in and modify it for a new user. And it's difficult to do. I have to use the highly intuitive :Y to yank the line, and then I'll use the P command to place the line. I then use the X key to delete the word guest. I then have to go into a different mode to insert characters. So I'll type an I and then my name, and then I have to get out of insert mode to move, and then I'll just change the user ID. You can see that this is difficult to use. Well, with AUX 2.0, there's a better way of accessing these text files. I can just double click the icon. You see password here. It's the same file we just edited. I'll just double click on that, and a utility called text editor is brought up. And in the familiar Macintosh way, I can manipulate this text file. So I can take the line guest, and I can copy that. I'll just reposition the cursor and paste that line and hit return. And you can see that I can then modify this in the familiar Macintosh way. I'll type my name in and then go over and add a new user ID. So this is just another example of the power that providing the Macintosh to Unix can present. So now you have access to Macintosh ways of doing very Unix-like tasks. Well, throughout these demos, I've used the Unix file system for all the applications and files that I've used. But you'll notice to the right of your screen that you have another hard disk icon as well. That's called a Mac partition. This is a bootable Macintosh partition. You'll see a system folder there. You also, in the upper right corner, see a hard disk icon called /. That indicates the root Unix file system. With AUX 2.0, I can keep my files in either place. The Unix or Macintosh files can be on either the Unix hard drive or the Macintosh hard drive. It just doesn't matter. A Macintosh floppy works the same way. I can take a formatted Macintosh disk and insert it. It'll appear on the desktop, and then I can either use the applications straight off the floppy disk, or I can copy them to either the Macintosh or the Unix hard drive. Turns out that integrating the Macintosh and Unix file systems was one of the biggest challenges the engineers faced, but it's been implemented flawlessly, and what it results in is seamless integration of two very different worlds for the user. Well, AUX 2.0 truly extends the Macintosh experience to Unix, and it does it in three basic ways. The first is the ability to have the Macintosh desktop on an industry-standard Unix. Secondly, the ability to mix and match different types of applications on the Unix desktop. And thirdly, the ability to apply Macintosh skills to daily Unix tasks. AUX 2.0 is a very unique product, and it truly extends the Macintosh experience to Unix.
Today we're introducing three new display cards for the Macintosh, the 48, 824, and 824 GC cards. The first card that we'll show you is the 824 card. This is a true color video card. It provides photographic quality realism on the Apple 13-inch monitor in color and photographic quality realism in black and white on any other monitor. The human eye can perceive about 7 million different colors. We've doubled that and supported about 16 million colors on this card, so you get very smooth, imperceptible gradations in color across the screen. Let me show you what we mean. Here's a picture of a photograph which was scanned into the Macintosh. This is 1 bit per pixel, or black and white. Here's the same picture scanned in at 4 levels of gray, or 2 bits per pixel. Here's the same picture with 16 colors, 4 bits per pixel, 256 colors, 8 bits per pixel, and the next one will be 16,777,216, or 24 bits per pixel. So here you can see this is photographic quality on a Macintosh 2 display. This new card, as I said, supports 24 bits per pixel, or 16 million colors on the Apple 13-inch monitor. It supports 8 bits per pixel on any other Apple display for the Macintosh. It runs on all Macintosh 2 systems, Mac 2s all the way up through the 2CI. It's compatible with existing applications and runs on all Apple monitors. It also supports interlaced video, TV standards, PAL and NTSC, through an adapter device. And what this allows you to do is take any presentation or animation and record directly off your screen to a regular consumer electronics style video tape recorder, and you can play it back. The architecture for this, the software architecture, is called 32-bit Quick Draw. It's available now and will also be built into System 7 as well. The second card that we're introducing today does all the things that the first card does. It's called the 824 GC card, except it does all these things a lot faster. Here to tell you more about that card is its product manager, Mark Gonzalez. Mark?
Hey, Randy. As Randy mentioned, we're adding graphic acceleration to the Macintosh today with the 824 GC card. Well, when we started the project, we really thought we had three main goals in mind in order to add this into the Macintosh environment in an integrated fashion. We had to make it transparent so that users and developers didn't have to go through any complex software matrix compatibility type issues. We had to make it complete in that we wanted to accelerate the entire imaging model, not only from graphics primitives such as lines and arcs and rectangles, but also in manipulating 24-bit images and also manipulating all the background data structures necessary, like window maintenance and region maintenance, that's necessary for a graphics user interface. And lastly, we needed to make sure it was extensible. So as Apple changed and evolved its system software in the future and its imaging model in the future, the card needed to change along with it. So what we've come up with is the 824 GC card that takes the power of an AM29000 processor running at 30 megahertz and uses that to run Quick Draw in a parallel fashion with the 68000. Let me show you some examples of that. The program you see on the screen now is called Diatom. Let me start it running here. It's an interesting program in that it was a shareware program written for the 128K Mac. And in fact, if you take that disk and stick it in a Mac 2CI today, it still runs. We've made one modification in that it's drawing in color today. And so this is the type of performance you can see with this application, drawing about 330 line segments per image, doing a number of floating point calculations in between each image on a Mac 2CI or Mac 2CX, excuse me, with a 824 card. Now what I'm going to do is I'm going to hit a key combination to take it from a normal Macintosh environment into an 824 GC environment. So you can see the difference between the normal environment and an accelerated environment. Now on the 824 GC card, using this application, you can actually get faster performance on each faster Mac that you put it in. So you will get faster performance on the CI and faster performance on maybe something else. Let's go back and see how this translates into some normal applications. What I have back here in Multifinder, under Multifinder, is Pixel Paint Professional by Supermac Technologies. Pixel Paint Professional is to 24-bit color what Mac Paint is to black and white images. So it allows you to draw and manipulate 24-bit images just like in Mac Paint, except obviously with a lot more freedom in color choice and blending and manipulating images. What I'm going to do is I'm going to just grab the hand tool here and enlarge the image a bit. And for somebody who is working with a document like this, you may want to move it around. So we're going to just take the hand icon and move the image around. And in a normal graphics environment, what you see is sort of a wave effect. And that occurs because of the massive amount of data that's being transferred from one portion of memory to another. So you get that wave effect on the screen. Now, we wanted to make manipulating 24-bit images as fast and as responsive as manipulating 1-bit images were in Mac Paint. So if I turn the 824 GC on again and do the same type of manipulation, as you can see, it's like moving a paper underneath. So this will allow people who create these images, to create the 24-bit images, to be a lot more productive in their work. But what about the people who are just using the images, who are importing the images into PageMaker documents or in word processing documents? Well, behind here, I won't save changes. Behind here, I have a very familiar application, Word 4.0 by Microsoft, and it has the text of the Constitution of the United States. I know, because I typed this in this weekend. If you have any questions, I can answer them afterwards. And what we've done is pasted a 24-bit image of the flag on top of the document. Now, one of the issues with doing something like this is that you had to give up something to paste that image in. You had to give up your text drawing speed, because the text now all has to be drawn into that 24-bit window as well. Well, so that if we use a normal environment, you see that same wave effect we saw in Pixel Paint Professional as the image is scrolled up and the text takes its place on the bottom. Well, we didn't want to make that compromise either, and so with I'll go to the top of the document, and with the GC card turned on, you see you get a nice smooth scrolling effect even in 24-bit color. In fact, you get smoother scrolling than you got during 8-bit color in a normal Macintosh environment today. So that even people who are using basic word processing documents who are working in 24-bit images can take advantage of the speed increases with the GC card. So that's a few quick examples of sort of a wide range of applications, from line drawing applications to basic productivity applications, that are accelerated using the GC card.
the Macintosh IIfx.
This is the most powerful Macintosh ever built. As the video showed you, the whole Macintosh II has been elegantly, artfully redesigned from the ground up. The whole system balanced from the processor to the input-output subsystem to the memory architecture, all balanced to produce the most responsive, the most intuitive personal computer ever created. By pushing the performance envelope of computing, we hope to change the way people use personal computers, to enable new kinds of applications, to help existing applications become even more responsive, to develop technologies at the high end of the product line, migrate them down into every Macintosh, and ultimately to change the way people work, learn, communicate, and play with personal computers. Here to tell you all about the Macintosh IIfx is its product manager, Frank Casanova. Frank? Hi. I'm sorry.
This is truly a wicked fast Macintosh. The Macintosh IIfx is a brand new design based on a number of new technologies and new architectures, some of which we're actually patenting, that provide a brand new level of performance, the highest level of performance ever in Macintosh computing. What we find happening with these architectures and technologies is we're able to push the forefront of performance faster than ever before. As a matter of fact, we're able to go up to 4 times faster than a 2X or a CX, and up to twice as fast as the mighty Macintosh II CI. This will enable all sorts of applications to go far faster than ever before, existing applications. But what we think is probably the most exciting thing is what's going to happen to new, exciting applications, new developments that will take place as a result of the Macintosh IIfx level of performance. So what I'd like to do today, before I demonstrate some of these really cool applications, is walk through the architecture of the IIfx after we start it up. Okay, we're happening now. This is the logic board. And what we've done is use the fastest available clock speed on the Motorola 68030 and 882. 40 megahertz is as fast as we can get in the kind of volumes that our customers demand. And what we've done is not just cranked up the clock speed. While certainly it's kind of central to the design of making things go fast, you have to wrap an entire architecture around a processor and a floating point subsystem to optimize performance and to balance functionality across the entire architecture. So in addition to this really fast clock, we have added manual controls to this presentation. 32 kbytes of static RAM, a very deep cache that allows us to execute with 0 wait states over 95% of the time. Now this is really key to keeping up with the speed of this processor, because when you're running a clock this fast, you don't want to waste a single clock cycle. So what this means is balanced performance. 95% of the time when the processor wants a new instruction or a new piece of data, it finds it in this cache. But if, for example, the application does something naughty like a goto, pops out of the cache, or if the user decides to change their mind as to what they're doing, we find ourselves in a big, fast DRAM subsystem. Either 4 megabytes of memory or 8 megabytes are the configurations on this machine. And we'll, of course, be able to go up to 32 megabytes and 128 megabytes as the 4 and 16 megabit chips become available. What we've done is enabled burst mode reads, just like the Mac II CI, which lets us get out to DRAM and get lots of information back in a far shorter amount of time. But something that we've done that's actually even newer than that we're patenting, is something called a latched data write. And this is simply our ability to write out to DRAM the results of a previous calculation at the same time we're reading in a new instruction from cache. And whenever you can overlap operations and provide concurrency over your control, you get higher levels of performance. So the combination of this processor, the cache, and this DRAM subsystem give us an entire CPU subsystem that is highly optimized and very tightly integrated to provide the highest possible levels of CPU performance. But again, that's not where it ends. It's important that you pay attention to everything else, like the users, people on the outside, and making sure that everything that we're presented with go fast as well. So what we've done is added a sophisticated, totally integrated, brand new I/O subsystem. The first components of this are brand new custom chips, of which there are 7 new custom chips on this, all designed at Apple, are called I/O processors. These are standard cell implementations of the 6502 CPU. The best way to think about these is we have 2 surface-mounted Apple IIe's on every IIfx logic board just to provide I/O performance and consistency. Because what these 6502 processors have is 32 kbytes of static RAM, out of which they execute instructions, into which they buffer incoming data that provide a low-level interface and free the main processor up from having to deal with things like Apple Desktop Bus, the floppies, and the serial ports. For example, if you're using a Macintosh IIfx as a gateway between 2 networks, network A is communicating to network B and streaming many megabytes of data across. The user of this IIfx doesn't even know that's happening because these I/O processors are managing all the low-level protocols and interfaces. We get some nice little side effects too, like the cursor moves smoothly when you're formatting floppies. You're going out to serial ports, and the floppies actually work faster. So we get concurrent operations across this architecture. We've also paid attention to the SCSI subsystem. SCSI DMA, as you know, is our SCSI bus, is where we put all our devices like disks, CD-ROMs, scanners, and the like. And And what we've done is added a dedicated DMA channel for this bus. And that gives us, again, the ability to do concurrent operations because it's an intelligent subsystem that when disks get fast enough to keep up with this chip, will allow us to go over 3 megabytes of data per second. So the combination of this integrated SCSI DMA subsystem, these I/O processors comprise a brand new interface, yet compatible look to the outside world of a high-performance, tightly integrated, balanced I/O subsystem that does, in fact, keep up with this high-speed CPU. One other area of performance comes along the lines of a new processor direct slot. Now, this is a big 120-pin connector that gives third-party developers and sophisticated end users a direct peek onto the processor bus for those kind of cards and devices that want to see that kind of performance. And when you couple this PDS slot with the new bus expansions, of course, there are 6 of them in this machine, you have a completely standard yet very high-performance way to get devices in and out of the machine. So the combination of all of these components, PDS, new bus, the brand new processor subsystem, and certainly the I/O subsystem, comprise to make the Macintosh IIfx the fastest, most responsive Macintosh that ever existed.
This is a demonstration of the new Apple II high-speed SCSI card in comparison to the previous Apple II SCSI card. The system on the right has the new card, while the one on the left has the previous one. Otherwise, the two systems are identical. They're both an Apple II GS with 1 megabyte of RAM on board, and there is not any additional memory expansion card. The software is being run off a 160 megabyte hard drive, and we're using System Software 502. For the first demo, I'm going to launch AppleWorks GS, a fairly common application. The new card takes about 24 seconds to launch, while the previous card takes about 35 seconds. So in this case, the performance improvement is about 40%. Now let's open a file. This is a 60K graphics file, and again, the new card is noticeably faster. It is important to understand that the performance improvement a user perceived depends on more than just the data transfer rate of the card. When you launch a program, there's much more going on than just transferring data from the hard drive. Similarly, when we opened this file, the computer first figured out where the data was, got the data from the hard disk, and then had to figure out how to display it. If we opened a very small file, the performance improvement would be negligible. We'll quit this application now. Now, let me show you a demo which shows the difference in maximum performance between the previous and new cards. In this demo, we transfer data as fast as possible from the drive to the screen. This is footage from the film The Empire Strikes Back, which has been digitized for the 2GS. We have approximately 30 seconds of film footage here. The film was digitized at a rate of 30 frames per second. With the new card, we're transferring slightly over 31 frames per second, and so this is a little faster than what you've seen at the movies. It takes about 28 seconds to go through the 30 seconds of film footage, and then the program repeats. The previous card, which is the system on the left, takes about 5 minutes to show the same thing. So the new card is up to 10 times faster than the previous card. The data transfer performance is a combination of hardware, firmware, and software. In the demonstrations here, both cards are using the same software. However, if we ran this demonstration with the previous card and System Software 4.0, it would be more than 60 times slower than the new card and System Software 5.0. Another factor in data transfer performance is the speed at which the SCSI device can receive and transmit data. If the device operates at less than 1 megabyte per second, the card has to wait for it, and the device becomes the bottleneck in the system. We're using the 160 meg drive because it can transfer data at almost 1 megabyte per second, and so is close to the limit of the card's capabilities. By the way, those of you familiar with the video overlay card need to be assured that we are not using video overlay here. This is data directly from the hard drive. In conclusion, the Apple II high-speed SCSI card provides the fastest data throughput possible for the Apple II user.
2 years ago, we started to explore what the future would have to be. Time was growing. Both the international and domestic edition were running more graphic elements in every magazine, every edition. What we had with our past systems was a workflow where every layout would have to be remade from one system to another system, and the work would have to be duplicated. In the new system that we envisioned, we were looking for color, open architecture, sophisticated software at a reasonable price, connectivity to other systems, and it had to be a platform that would grow, that would allow us to expand over the next few years. The system that met those requirements was the Macintosh. Being able to do our color scanning on a high-end pre-press system dedicated to that purpose, and then electronically and transparently pass a copy of that photo to the Macintosh has allowed the artist to work much more directly with a final version of the photo, not a separate copy of the photo that can never be reused again on another computer system.
We have about 30 Macintoshes in the art department for primarily designing the pages, but also creating the illustration maps and charts.
With the Mac system now, the artist goes in, sits down at her desk, and resketches the layout and shows us something within 45 minutes or an hour. I can show you 2 examples of that. This is a cover that we did on defense costs about 2 weeks ago. We wanted to write this headline, "How much is too much?" and we needed to have a fairly long subhead for it. Under the old system, that would have taken us hours, maybe even more than a day. Now, this isn't a question of flexibility. This is just a question of capability. This was an idea that we came up with at the pretty much at the last minute to add to this cover. What would the soldier of the future look like? And we were able to completely design this on the Macintosh as we went along.
Well, what is terrific about the Macintosh is that somebody can work in their room a block away down the hall, put what they've done on a server, and a layout artist can pull it up and put it onto their layout, which gives for accuracy and speed.
Well, for me personally, since I work on the covers, this used to take me hours, 4 or 5 hours to present, put together a layout, and we thought that was remarkable. To get a C print, to get the typeset, to get color keys made. We thought we were doing a good job in those days, but now we can do this in about 20 minutes. I'm selling my type machine.
My drawing board is leaning up against the wall. It left my table just last week, and I'm not sure whether it will ever come back.